new challenge in different fields. Let's move regarding the focus of DECOR Workshop and some history. So as you know, we eat every day, so cooking is very important, it's part of our life. Of course, food is related to our culture in terms of food perception, habits, and different way of practice, cooking, choice of ingredient pairing, and so on. So that's important. Also with large-scale data, big data challenges, and different kind of type of collection, recipe collection, nutritional data, food carbon print information, and so on. So where we are able to share different kind of also experience and feedback in terms of social media. Recently, new developments since 2011, multimedia knowledge, multi-sensing perception of food and dishes in terms of how we can express our expectation and how we can share our experience and the gap between perception, expectation, and feedback. Of course, there are new perspectives in computer vision in terms of new kind of representation, new kind of data engineering, combining the knowledge, food, and how we can interpret or compress the ingredients, the food we are using or the food we are expecting. Of course, in terms of social media, more and more network where we can share, and at the same time, we can also recommend some special dish and share our passion of enjoying some special food, and how collective intelligence can be part of this dish experience sharing and feedback. So the objective of today's workshop is more and include a concrete contribution with new model. We will have some interesting presentation and keynotes on research design and new way of building ontologies to help to develop model for computational cooking, digital food, and also food sharing, and how the way to design data management as intelligent tools will help for computational cooking. Of course, we have new rich multimedia cooking recipes dataset, where we are trying to share different kind of multi-sensing feature of this in this dataset. The history, so this year in Dallas, we are very proud for the third DECOR workshop. We started in 2018 in Paris and last year in Macau. So it's my pleasure to also, as a special guest, to welcome Dr. Janet Nussli-Gut, member of DECOR Steering Committee, as a special guest, and maybe let's see if Janet is around to give some. Hello.
Hi, I'm here.
Yes, Janet. So from ETH Zurich, Department of Health Science and Technology. I couldn't see you in the list, so it's good. Yes, please, if you have some special word and remarks according to our challenge, as you participate actively in Paris DECOR Workshop 2018 and the Macau Workshop 2019. Thank you.
Thank you, Frederick, for the introduction and giving me the chance here to say a couple of words. So welcome to everybody in this virtual DECOR workshop, and greetings from Switzerland. Yeah, I'm a food sensory scientist by training, and I especially deal with the experience of people expressing their sensations while eating and drinking, and try them to verbalize them. And what is very interesting to me in this context really is that one tries to put that one tries to extract the important data, which would food science usually doesn't do. And I think crossing borders in that context really gives a high value to the field. Yeah, unfortunately, we are unable to really perceive any food during this workshop together and exchange our experiences, but I'm looking forward to all the interesting presentations.
Thank you, Janet, for this this sharing. Also, we would like to share our all our concern and compassion with our friend from Dallas and USA and all over the world with this in this difficult period of time. And we hope that we will be able to meet soon sometime in Lebanon, but we also share our compassion for all who are suffering or will suffer from the virus, and we hope that everything will be better soon. That's yeah, good thing for that. Let's move now to yes, to our first keynote. So let's introduce Professor Alan Abner, who will give a special talk on daring to good design science research. I would like to introduce Professor Alan Abner as a distinguished university professor and eminent scholar in the Information System and Decision Science Department in the Mumma College of Business at the University of South Florida. He holds the Citigroup Eden River Chair of Distributed Technology. Of course, Dr. Abner's area of research interests include design science research, information system development, software engineering, distributed database, healthcare system, and Internet of Things computing. We all know that Professor Abner published over 250 research papers in these topics and has been consulted for a number of Fortune 500 companies. He received his PhD in computer science from Purdue University. He has held faculty position at University of Maryland and the University of Minnesota. Dr. Abner is a fellow of the American Association for the Advancement of Science, AAS, a fellows of the Association for Information System, AIS, and the fellows of IEEE. He is a member of ACM and Informs. Additional honors include selection as a Parnas Fellow at LERO, the Irish Software Research Center, scholar senior fellows at Friedrich Alexander University in Germany, and the 2018 Distinguished Alumnus Award from the Purdue University Computer Science Department. He served as a program manager at the US National Science Foundation, SF, in the Computer and Information Science and Engineering CICE Directorate between 2006 and 2009. So it's my pleasure, and we can clap virtually to welcome Professor Alan Abner for his talk on daring to good design science research. Thank you.
Well, thank you, Frederick. I appreciate the opportunity to participate in this exciting workshop. It's a pleasure to sort of show and demonstrate how good design science research can apply to many disciplines. So let me share my screen here. Here we go. Okay.
Just, Professor Abner, just comments, as we may not have time to reply or to answer to all the questions during your talk. Don't hesitate to add or to input the question in the chat. So we will collect all the questions, and as you know, we will have at the end of this workshop day a special panel discussion session where we will be able to come back to all questions collected from each session. Thank you.
Okay, very good. Yeah, I was going to actually mention that you know, as we go through this presentation, I'm sure there are going to be a lot of questions. So I look forward to the opportunity to answer those questions later this afternoon. Also, as you'll see, I have my email address on the front slide here. Feel free to correspond with me on email. Happy to share some ideas and knowledge on how to do good design science research. Also, as we go through the presentation, you'll see a number of references to papers that we've published in this field. If you don't have access to those papers, again, just contact me and I'd be happy to share copies of those presentations. Okay, my goal today is to acquaint you with design science research, what it means to do good design and to make it science. I want to provide at the beginning a set of foundations, and then I want to address some challenges that we have in performing good design science research. Let me say that I've read through all the workshop papers, and I truly believe that food science is a great opportunity to do good design. So you'll see that I've sprinkled through my talk some references to food science ideas and contributions. And I look forward to, again, interacting with all of you. I regret we can't do this face-to-face right now, but let's make the best of this. So let me go ahead and get started. I always like to open with this quote from Theodore Roosevelt. I really think it's important as we do research that, as you read through this quote, that we spend time in the arena, working with practitioners, doing research that really makes a difference. And in the end, we need to dare greatly. And so that's why I title this talk, Daring to Do Good Design Science Research. Just briefly, to set, again, some foundation here, doing design as science is a pragmatic, problem-solving paradigm that seeks to contribute to human knowledge via the creation of innovative artifacts. And this is clearly engaged scholarship in which we work with practitioners, users, clients, sponsors, and other researchers to understand and address an important problem and opportunity. So you'll see that typically DSR projects are team-based, longitudinal, goal-driven, and they inform multiple audiences. So as we dare to do good DSR, it's really not a journey for researchers who value optimal, repeatable results. Why? Because if we try to rely on existing theory, we often find that theory doesn't really apply directly to our situation. We argue that it's better to start doing multiple rapid cycles of build and evaluate to produce emergent and satisfactory results. Even then, as we put our results into the problem space, we find we change the problem space. Therefore, we're sort of never looking at the same challenge again and again. So doing good DSR is a challenge. It's an audacious venture, but it's also fun. It's satisfying, and you change the world. Again, as I've looked through the papers in the workshop, as we develop innovative artifacts and design new solutions, we characterize artifacts in 4 ways: as constructs, models, methods, and instantiations. And I found all of those 4 constructs throughout these papers. The ideas of constructs, flavors, ingredients, cuisines, the models we build, whether they're analytic, visual, or finding patterns in data, understanding how to build connections and models. And then the methods that we develop in terms of algorithms, recipes, best practices, say recommendation algorithms. And then finally, the instantiations, which are the actual physical systems that we build around these ideas. And then we intervene in terms of action research, co-design with practitioners, and at the same time, we do rigorous evaluation. We evaluate both in the laboratory as we're building these artifacts, but then in the real world in terms of case studies, field studies, as we put these artifacts to practice. And then as we reflect and learn from our experiences, we build what we term as nascent design theories around why and how these artifacts are used in practice. And over time, because most of our projects are longitudinal, we accumulate and evolve the design knowledge that we're discovering in our projects. So a little bit of background. Clearly, design has been prevalent throughout history in many, many fields: engineering, education, even the arts, music, architecture. Design focuses on the roles really of creativity and collaboration, bringing people together from diverse backgrounds who are able then to provide a creative aspect to building new artifacts and innovating around them. Really, most recently, Herbert Simon, Nobel Prize winner, economist, wrote a very important book called Sciences of the Artificial. Very readable book. And what he describes in that book is really design science as a pragmatic research paradigm. It's the creation of innovative artifacts to solve real problems. And with colleagues, I have sort of led the idea of adding design science research into, in particular, information systems, which is my discipline. But I've presented this material to many, many disciplines, education, all of the business disciplines, really throughout many international talks. So here are sort of the basic publications. The first one being our MISQ paper in 2004. Then my colleague Shirley Gregor and I extended that in an MISQ paper in 2013. And more recently, with some other colleagues, we've talked about finding that right balance between building that artifact and forming theory around how the artifact is used. I think an important observation is that design science really fits in this interface between the rapid development of new technologies and the slower paradigm development of understanding and science around these technologies. So I think this is an important thing to understand, is that we're at that interface where we want to understand how new technology operates, and then how do we build nascent theory and understanding around that artifact. So let me just cover a couple of the figures from the basic papers. This is probably the primary figure from the 2004 paper. It shows that a design science research project draws relevance from the real world environment, the people, the organizations, the technology, and it draws its rigor from the existing knowledge bases of the world. And we'll talk a little bit more about that in a second. But the theories, the frameworks, the methodologies that are out there by which we do good science. And then the middle, the actual research cycles where we build artifacts, we evaluate them, we do a number of very rapid build and evaluate cycles, and then we make two key contributions via our research. We add the artifact into the real world context. We understand, does it solve the problem? How can we do even better? But at the same time, then we add knowledge to the knowledge base in terms of nascent theory, data, more understanding of the environment that we're working with. That 2004 paper also provided a set of guidelines that people, when they do good design science research, should evaluate. It's not a rigorous checkoff, but you need to understand these guidelines as you do your project. What is your artifact? Why is your problem relevant? How have you rigorously evaluated the effectiveness, the utility, the qualities of your solution? What contributions are you making both to the real world environment and into the knowledge base? Again, how did you appropriately draw from theory, from experimentation to do your build and your evaluate, the rigor? Number 6, how did you decide on the best designed to implement? As you know, there could be many, many possible designs. How did you evaluate and decide via search that the design you're implementing is the one that would be the most satisfactory? And then finally, how do you disseminate your knowledge that you've gained from your research? Then in the 2013 paper with Shirley Greger, we addressed the issue of what is the artifact and how do you interpret the artifact as new knowledge? And we recognized that based upon the maturity of both your problem space and your solution space, your new knowledge could be at level 1, the actual situated implementation and instantiation, solving the problem. At level 2, where we understand the problem a little better and we want to start building knowledge as operational principles and architecture. So we want to be able to generalize our findings via methods, models, principles, and rules. And finally, at level 3, where we build well-developed design theory about the phenomenon that we're studying. And this would be termed mid-range theories or grand theories that start to more fully understand and generalize the knowledge that we've gained. So again, we can make contributions in our research based upon the maturity that we find ourselves in terms of our problem space. That leads to this 2x2 matrix that many people have found very helpful in understanding their research. As you'll see, the x-axis is the maturity of the problem space. The y-axis is the maturity of potential solutions to solve your problem. As we look at the upper right, if you have a new problem, there are very few, if any, solutions for that problem. This is the invention quadrant, inventing new solutions for new problems. Upper left, we have a more full understanding of the problem space, but we find no good solutions. Therefore, we're building new solutions for known problems, and this is the improvement quadrant. Bottom right, here it's a brand new problem. We haven't seen it before, but there are potential solutions from other problem spaces. We can adapt other solutions and extend known solutions to new problems. And really, there are many cases of that. And I term that exaptation, where we take an existing solution in a different space and adapt it or exapt it to our problem space. And finally, the largest quadrant at the bottom left, routine design. We understand the problem. We know there are good solutions out there. They may be new to us, but again, they're out there. So this is best practices, it's professional design, but it's a challenge to find a research component in that bottom left. So really the 3 quadrants, improvement, invention, and exaptation, are where we as researchers should be working. Now let me move from sort of the foundations of design science research to some challenges we're facing. And as I go through these fairly quickly, maybe just 2 or 3 slides on each, I want to bring out the challenge, make sure that you understand, why we as researchers have to deal with these type of challenges, and provide some maybe initial solutions and some of my thinking toward this. So let's start with complexity. I think this is really a key challenge that we all face. We want to do research in complex problem spaces, and food science is clearly an example of that. So from the field of complexity, we know complex systems are diverse, interdependent, connected, and adaptive. In the information systems field, we feel that our problem space deals with complex socio-technical systems that bring together technology and human behavior. And we attempt to manage complexity by really capturing, representing an important and interesting problem space. And we define that problem space via the context, who are the stakeholders, what is the application domain, goodness criteria, what are we trying to accomplish? What do we want to achieve with our research? What are the goals? And how do we measure completion of those goals? And finally, understanding, again, via this complexity idea, that the problem space dances. We have a dancing landscape in that when we put our solution into place, emergent behaviors come about. We find that systems self-organize. Things change that we didn't anticipate. Therefore, our problem space is, and this is a term from the field of complexity, it dances on us. And so we need to keep that in mind. Now let me share with you a little bit of thinking that we've done on a particular issue on, when we do good design, what are we trying to accomplish? What are our goals? And as you read through these questions, you can see that clearly we need to recognize there are many different stakeholders. Each of them may have different goals for our solution. How do we prioritize and weigh these goals in a utility function? Then how do we measure whether we've achieved these goals? So how do we evaluate the overall goodness of fit of a designed artifact as a solution? And this helps us, if we do have a good utility function, rank these potential design candidates. So this is something that the research team needs to be very careful and rigorous about as they define their research projects. And we've done some initial thinking on this. Here is a working paper that we presented about 1.5 years ago at a workshop. As you can see, I'm working with some colleagues in Paris on this. Let me just give you sort of a flavor, if you will, of our thinking here. Drawing from Maslow's hierarchy, we feel that as we look for solutions in a problem space, we need to build our goals from the ground up here in this type of pyramid. Starting with, does it work? Does it have utility for the problem space? Then, is it safe? Do we have safety goals? Do we have interaction, communication, user interface goals? Finally, cognitive, or not finally, but cognitive aesthetic goals. And finally, innovation goals. Is it new? Is it disruptive? Does it make a research contribution? And then I filled in the pyramid with some measures of evaluation. And some of these are hard to make quantitative. Some of them are more qualitative measures. But clearly we need to think through this for our project. Now, and again, I recognize that it's difficult to have 20, 30 goals like this and measures. So what we need to do is prioritize, understand, what our research project is attempting to achieve. What are our goals? How do we measure them? Let me move to creativity. Really, the essence of good design is enabling and harnessing human creativity. human progress, and economists have known this for many centuries, occur when creative ideas are realized in design artifacts, products, services, and when markets are formed to produce, trade, and use these artifacts in efficient and effective ways. So here are some challenges, and I really, at this point, relate this to a lot of good and interesting, exciting research in the neuroscience area. In how do we enhance and support human creativity. So again, I won't read through all of these questions, but as you look at them, you can see that, you know, there's some real research challenges out there on how we best support designers to do good design science research. Issues such as trust, diversity, personality, collaborative performance are all sort of important discussions here in this space. Again, I'm putting a reference there, and this paper is available at the European Journal of Information Systems on their website. I think it's going to be published, or has been published, in one of their recent issues here. But again, some colleagues where we have published a paper called Advancing a NeurosIS Research Agenda with 4 areas of societal contributions. And what I've contributed to this paper is a discussion of good design and enforcing, enabling creativity. Another project that we're just sort of initiating with my colleague Matt Malarkey here at USF is a study of human values and how those impact good design. We have actually notebooks from 2 very, very creative individuals. One is an architect who actually was the designer of the Salvador Dali Museum in St. Petersburg, Florida, which you see at the top picture. He was also actually the project manager for the pyramid entrance to the Louvre, based on I.M. Pei's vision. The second person is an artist, Theo Wojcik, who unfortunately has passed away, but he was a master printer to the avant-garde artists, Andy Warhol, et cetera, in New York in the 60s. He also became a critical multimedia artist himself, and this is one of his pictures at the bottom right. But an initial review of these notebooks show that design is hugely impacted by human values and individual vision of the creator. And so understanding that as part of design, I think, is important. Now, the next one is causality, and let me put a context here. You know, we are part of the International Conference of Data Engineering, and I think design science has a lot to say on this new push for a lot of good data science research and big data research that's going on there. And I know a lot of us in the field of food science deal with huge data sources. So, you know, how does design come to play in doing understanding of big data and data science? Well, I think the role of data artifacts and building of causal models around that data remains largely unexplored. We aren't doing a good job of talking to each other right now. So again, with my colleague Shirley Greger from Australia, we had a working paper in the most recent ISIS workshop in Munich. So let me just give you a couple of ideas from that paper. As I mentioned, this idea of, as you do big data research, data analytics research, you need to capture understanding in innovative artifacts. So as we go through inductive reasoning, deductive reasoning, and abductive reasoning, it's important that we capture our understandings in some type of artifacts. So let me just show you this diagram. As we move from theory to data, we want to be able to creatively build, design, and data artifacts around the theories that allow us then to interact with the data that we're manipulating, that we're attempting to find patterns in. As we start from the data and do inductive reasoning, capturing those patterns, those observations, from repositories, logs, and transactions, and building constructs, models, methods, and instantiations around that data support, I think really rigorous, relevant data analytics research. So this is really something we're still exploring. I have drawn a lot of my thinking from Judea Pearl's work on causal modeling. And I think he really has a lot to say about how do we intervene in real world situations, and then how do we do counterfactual reasoning about how data and artifacts can play in good data analytics research. So let's move on. The next point I want to make is confidence. And this gets into the idea of trust too. How do we have confidence? How do we trust our results? Okay. Design science research is clearly an evidence-based science. When we put our artifacts into use, we want to be able to gather data and demonstrate evidence that we are satisfying the problem, and this is predicated on the rigor of our evaluation and the resulting evidence of goal improvements. So I like to use this figure just to provide, I think, an important context to what we're doing. And that is drawing from the problem space with its context and goodness criteria, moving then to the solution space where we have a lot of technology, potential solutions, and we draw from our knowledge bases to build solutions that we build and evaluate. And you'll notice I term evaluation in the solution space formative, because we're doing evaluations, if you will, in the laboratory to demonstrate and to refine our artifact before we put it back into the problem space. Now, when we intervene and we put our artifact and solution to work, then we have really two types of summative evaluations. One, fitness for use. Does it solve the problem in a satisfactory way? Okay. Does it work? At the same time, we need to evaluate fitness for evolution. And again, I draw back to the dancing landscape in that maybe it works now, but our problem space is continually changing. Therefore, does it have criteria for evolution? Is it sustainable? Will it adapt effectively to changes in the problem space? Or will we have to throw it away and start again with a new design project? So we want to evaluate both, does it work, but is it evolvable? Is it sustainable over time? Now, in the 2004 paper, we discussed, if you will, a toolbox of evaluation methods. And here is where the researcher skill comes in to say, okay, how do I do formative evaluations? How do I do my summative evaluations? How am I going to convince and provide reviewers, editors, practitioners with confidence that the solution will work? Okay, so you can see we range from qualitative evaluation, quantitative evaluation, analytic, experimental, testing, descriptive. So, build your toolbox as a researcher, and then as you do your project, select appropriately and carefully how you propose to provide the evidence for the claims you're making for your solution. And here's just a quick slide of how you go through that process. You want to match your methods to the research question, to the design goals, to your hypotheses and dependent variables, to your application context. I mean, what availability do you have to intervene in your problem space? What data sources do you have? Qualitative, quantitative, primary, secondary? What are the skills of your research team? And what tools can you bring to bear? And you may have different methods of evaluation for your formative versus your summative evaluations. Okay, now let's talk just briefly about the challenges of controlling your project. What process are you using in your research? Clearly, as you write your papers, you need to have a rigorous, well-defined research process. So people over time, and I've listed a couple of papers here, have defined processes for conducting and controlling good DSR. Also, recently, the whole field of action design research has become very, I think, visible and important in our field. And there was a seminal paper in 2011 discussing how we combine good action research with design research. So let me expand on some ideas that I've had here with, again, my colleague Matt Malarkey. A recent paper has appeared in the European Journal of Information Systems on how you perform good action design research, and we term this an elaborated action design research process. So we want to provide the opportunity for you to intervene in the problem space in several ways. Are you starting out trying to understand the problem, diagnosis? Are you at the point where you're ready to design potential solutions? Once your solutions are proposed and designed, how then do you do the actual implementation and intervention into the problem space? And then if you have a system in place, how do you think about the evolution and sustainability? So there's opportunities to intervene in an action design research way at different points in the process for good action design. Now, each of those cycles, I think it's important to expand what activities you're doing, whether it's diagnosis, design, implementation, or evolution. You start your cycle by understanding the problem. Then you create your artifact, you evaluate it in a formative or a summative way, and then you reflect and learn on how the artifact has solved the problem. And here's where you're building your nascent design theory, your principles, your generalization to say, okay, how will I represent and present the knowledge that I'm building so that other people can use it, so that we can use it in the next cycle of our design. So this is a fairly well-defined process that we have presented to a number of people, and they found it very, very appropriate for their research thinking. And this type of, I think, well-defined control, well-defined process supports really the intellectual control of your research project. As you'll see, in a recent editorial in MISQ, I provided a small part of that editorial. But the point I was making here is that doing good design in rapid cycles really provides a way to give us intellectual control of complex problem spaces. So you'll see in the second bullet there, one of my arguments is extensive search for applicable theories on which to ground design and predict behavior is unlikely to be fruitful in really complex environments. Therefore, the argument that I make is that it is better for the design team to begin immediately these rapid cycles of building and refining an artifact And then once we see the impact of the artifact, then we can reflect, we can learn, and we can start building more appropriate and more relevant theories around why the artifact works the way it does. So I've listed some key control questions here, but it's, again, something to think about. How do we generate and build good new knowledge around our artifacts? Next, what does it mean to make a contribution to new knowledge? And here I draw from the economics of knowledge literature. Basically, there are two basic types of knowledge. There's descriptive knowledge that helps us understand and describe the world, phenomenon, sense-making of natural phenomenon. And then there's prescriptive knowledge, which is what we deal with in good design research. And this prescriptive knowledge are artifacts and the design theories that surround these artifacts. So this is a fairly complicated diagram. Again, there's a reference here. But you'll see at the top, here are the projects, the problem space, the solution space, the evaluations. And here's how your project, the projects we do, interact with the existing knowledge bases of both descriptive knowledge and prescriptive knowledge. So in this paper, we defined sort of six modes, three of which are consuming existing knowledge, three of which are producing new knowledge into the knowledge base. So as we perform good design science, we think about, how we draw appropriately from existing knowledge and what new contributions we're making into existing knowledge. So, I'll let you think about that. And again, the paper that I did with, again, a colleague, Andreas Drexler, we talk about how research projects interact via these modes. Also, we talk about how does DSR make an impact into the world, because that's a contribution. How are we changing? How are we improving the human condition with our project? And I think your reflection as you discuss the impacts of your project need to deal with this. And our argument here is artifacts are the vehicle for the dissemination of knowledge. The ideas, the design theories are embedded in the artifact, and they impact practice, and they also impact scientific research via the use of the artifact and the dissemination of ideas and nascent design theories. Which moves us to, again, the idea of how do we accumulate this knowledge over time? How do we draw from what other people have done? How do we then provide the ability for other people to use our design knowledge? So a recent paper that I worked with several colleagues from Europe, again, it will appear this year. I think it is on the website right now, the Journal of AIS, where we talk about accumulation and evolution of design knowledge over time. And we recognize that this is a challenge because it's difficult to understand what people have done that have come before us, particularly with this idea of a dancing landscape. We always think we're dealing with a problem that nobody has dealt with before. So we need to have better ways of communicating, our design knowledge and using design knowledge that exists. So we miss the opportunity to produce reusable design knowledge. We miss the opportunity to consume and compose relevant design knowledge contributions. And one of the things that's really missing is, if you will, tagging design knowledge as to its currency, its timeliness, its rigor, its confidence. So we need better ways of capturing and, if you will, cataloging in a repository what design knowledge we've produced. In this paper, and I'm not going to go through it because it's pretty detailed, but we have a sort of a three-dimensional representation that we term a design knowledge map. And the three dimensions are projectability, or how does the knowledge we've generated, we've presented in our project generalize to other problem spaces. Fitness, how well does it solve the problem that we are attempting to achieve here? And finally, confidence. You know, how confident are we in our result here? And over time, we define what we term design knowledge journeys. And here's just a quick example. Again, the idea of three dimensions: fitness on the x-axis, projectability on the y, and confidence as a third dimension. And we've used these type of balls to demonstrate the confidence as we filled in. So you'll see that here's a particular design knowledge journey, starting out very focused, solving a very particular problem that we have a great deal of confidence in our solution. Our next step might be, okay, let's try to generalize it to other projects, other environments where, again, we study it, but maybe we don't have quite as much confidence in our evaluation. Then maybe moving down to the right, making a more fit solution, but again, perhaps losing some of the projectability. So you can see as we go over time that there are reasons why a research project would go in these different directions to achieve greater projectability, greater generalization, better fitness to solve a specific problem more rigorously, or getting more confidence. You know, maybe this is where some ideas of repeatability, and that, well, let's do a similar project, but let's do it in a different, and evaluate it in a different way to provide more trust, more security, more confidence in our result. So I hope that appeals to you, and take a look at that paper. We go through a number of sort of scenarios as to what it means to accumulate and evolve design knowledge. Okay, the final challenge, and this is a real key one, is how do we collaborate? How do we build teams with diverse skills? And how do we engage a diverse set of stakeholders and collaborators in our project? And what our goal here is really a collaborative emergence of contributions from the design team, where we take advantage of talent, energy, skills, and come up with a solution that is, if you will, greater than the sum of the individual contributions. Now, as I think about collaboration, and I really haven't done a lot of research in this space, earlier, you can see this paper is from 2014 with some colleagues. I thought about this whole idea of how do we move from the external environment to, again, sort of a neuroscience, NeurolS way of thinking, to how people deal with complexity, creativity, control. We've talked about those, but also how do they deal with this idea of collaboration? And there is neuroscience literature that support ways of enabling, building tool sets to help people collaborate. We're on one right now. The ability to work together, to interact with one another virtually is a tremendous support for collaboration. But how do we, sort of build a platform and infrastructure to support collaboration based upon the latest and greatest ideas from the neuroscience field? Now, let me turn to some thinking about how to apply these ideas into the field of food science. I have, collaborated, worked together with Frederick, with Maria, thinking through how we would apply some design ideas to some projects they're working on. Here's a project, the Flavor Lens project. And you can see, just looking at this diagram, the design cycles, understanding the problem, okay, and capturing the problem space in representative models. But here's sort of an interesting insight we had in our discussions, and that is there were really two types of design in this particular research project. There was building the actual Flavor Lens platform itself, which is the internal design of the mobile tasting application system. But in parallel, at the same time, there needs to be a design project that says, how do we build the user experience? How do we design it using the tasting application? And we term this the external design. And these could be very different design projects with different goals here. But overall, they need to interact with one another and play off of one another. As you're doing the internal design of the system, that's going to impact the user experience. As well, the user experience should impact the internal design of the system. And so that's an important, I think, observation. And then as you run your experiments and gather your data, clearly you need to do rigorous evaluation. And again, design says something about how do we design our understanding, our way we represent the evidence we've gathered. How do we communicate that evidence? And then finally, how do we reflect to produce design principles that would allow somebody to come back and say, okay, now I understand the design knowledge you've generated. I want to take it the next step, or I want to do something different in my experiment. So a lot of design, I think, insight, synergy goes on as you think about a food science project here. On the next slide, this is my reaction to the workshop papers. As I read through the papers and the authors who were going to present these papers, you're doing a lot of great design here. As I read through them, I identify a number of innovative artifacts, such as design models, data models for recipes, methods to extract ingredients, models of nutritional profiles, methods to identify alternative ingredients in recipes, constructs, cuisines, okay. What does that mean? Modeling cuisine, visual models, analytic models, and finally, actual instantiations. You're building systems in GitHub and other places. Of course, the second part of this is how do you evaluate the goals that you're setting in terms of utility and impact? So I can see in the papers, you've identified your goals, you've identified measures of how you're evaluating those goals, and how you're demonstrating this via rigorous evaluation of the artifacts that you've generated. So, hey, there's some great design science research going on here. So let me wrap up by just saying that, I think this research methodology, this research paradigm really does support rigorous and relevant engaged scholarship in many fields to include food sciences. It's important to understand how our design work bridges the rapidly moving fields of technology with the slower, more thoughtful fields of how do we build good design theory around and make it a scientific endeavor. We want to identify clear, important impacts of DSR in solving real problems and in accumulating and evolving really human knowledge. So, final statement, daring to do good design science research requires the researcher, the research team to face these challenges of complexity, creativity, causality, confidence, control, contribution, cumulative knowledge, and collaboration. And let me leave you with just a very simple quote. So, thank you.
Thank you, Professor Abner. Thank you so much for your interesting and inspirational keynotes. So as we introduced before, just reminding to the attendees that all the questions should be shared in the chat, and we will use them, and the question will be answered during the panel discussion. Thank you. Can I have I share the screen, and now it will be our break. Where's this one? I have to share. So it's now it's a break. We have a 30 minutes break, and we will meet all together at 10:30 for the first session, paper session. Thank you so much, and talk to you soon. Thank you. Bye-bye.
Okay.